For today's lesson, we're talking about triangles, angle-angle similarity. Our essential question is, how can we use angle measurements to determine if two triangles are similar or not? Please take a moment, pausing the video if you need to copy the topic and essential question in your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So I'm going to give you a moment to think about this question here as you draw this diagram in. Is the teal triangle similar to the purple triangle? What information would you need to know, or what would you need to be able to see to be able to prove that whether or not they were similar? Well, for starters, we want to make sure we're clear on the definition of similar, which means that they're the same shape but a different size. But what exactly does that mean? We've said that a lot in class, but what does it mean to be the same shape? What gives them shape? What gives them size? Well, to answer that question, it's the angle measurements that give them shape. So if we're trying to figure out if two triangles are similar, we have to know that they're the same shape, so we have to know their angle measurements. And I could drag this over, we could do a translation, and I could slide this over, and we could compare. It looks like this angle matches up perfectly there, so those two angles overlap. I could translate it down and to the left a little bit. Looks like those angles match up. And if I go here to the top, translate to the top, it looks like if I aligned it a little bit better, it looks like those would. So it looks like they do share, all three angles are similar, and we definitely can tell that they're a different size. And let's be clear about what gives them size. It's the side lengths that determine size. And so for this question, we weren't given any information, but I was able to drag this around, do some translations, and prove that because they overlap, that all three angle measurements do in fact match up. And so these two triangles are similar. But we're going to do some work today with angle measurements to see what is the most minimum amount of information that we need about two triangles and their angle measurements to prove that they're similar. So we've already learned two theorems about triangles, and we're about to learn a third. It's called the triangle angle-angle similarity. The triangle angle-angle similarity theorem states if two pairs of corresponding angles are congruent, then the two triangles are similar. You might be wondering why we only need two pairs of corresponding angles. And the answer lies in one of the theorems about triangles that we've already learned. And that is the triangle angle sum theorem. Do you remember what that one states? This is the theorem that says that the sum of all interior angles is 180 degrees. So, if you can prove that at least two, say this one and this one, are congruent, and then the second will go with the bottom left angles, if we can prove those two are pairs of corresponding angles that are congruent, then we already know the third must be, because they must be the same number in order for them to all add up to 180 degrees. Let's go ahead and take a look at this in practice. So here we're being asked if these two triangles, triangle ABC, is similar to triangle JKL. And we only need to know two angles. Well, right here I can see that angle A is 18 degrees, and so is angle J. So angle A, so knowing both angle A and angle J are 18 degrees, we know that that is one pair of corresponding congruent angles. And now I look at angle B and angle L, they definitely don't look like they're corresponding, and they're definitely not congruent. But we have a missing angle K and a missing angle C that we're unsure about. We don't know those measurements. So we're going to use the angle sum theorem on one of the triangles to find the missing angle, and then we'll compare it to the other. So I've started to write it out here, and I could have chosen C or K, but I went ahead and decided to find the measure of angle K. And I know that angle J, K, and L all have to add up to be 180 degrees. That's what the angle sum theorem tells us. They all add up to 180 degrees. So if I add up 18 and 28, I can subtract that from 180, and that will tell me the measure of angle K. So let's go ahead and do those calculations. Go ahead and pause the video, do your work, and then let's check back in just a moment. Okay, so I found that 18 plus 28 was 46 degrees, so that's adding these two angles up here. And if I subtract 180, subtract 46, I'm left with 134. So the measure of angle K must be 134 degrees. So what I can see here is that I can't match up. I have two of these angles and I have three. I can only match up one. There's only one corresponding congruent pair, not two. And so there's no way that these two triangles are similar, even if they might look similar. They aren't, because I can't match up and find two pairs of congruent angles. So we would record that these two triangles are not similar because they do not share two congruent angles. Let's try another one. In our next example here, we now have triangle LNM, and we're trying to see if it's similar to angle XYZ. So again, right away we can see angle Z and angle N must be corresponding and congruent, so we can imagine rotating these so they're going the same direction. But we need to find out one more angle because these two angles don't match up. So again, we could choose angle M or angle X. I'm going to go ahead and try angle M. So knowing that all three angles have to add up to 180, we're going to write our work out again and see if we can find an angle M that matches up to 75 degrees. So again, feel free to pause the video and do your calculations and check back with me when you're ready to compare. Okay, so I set up my math sentence, again finding the measure of angle M, find adding together 40 and 65, and that got me 105, and then subtracting that from 180, so 180 minus 105 got me that the measure of angle M is in fact 75 degrees. So this angle here is 75. So now we can say, oh look, N corresponds to angle Z because they are congruent and they're both 65 degrees. M here, which we now know is 75, corresponds to angle Y, which is also 75. And so because all the angles have to add up to be 180, angle X also has to be 40 degrees, but I only have to prove it with two angles. So we proved that N and Z are congruent, M and Y are congruent, and so we can now say that these two triangles are in fact similar, and that's the symbol we would use for similar. And we would write our statement out, and then I have one more problem for us to practice. And here's how we officially write it out. So we would say yes, and here's our similarity statement. We say that triangle LMN is similar to triangle XYZ. And the reason we know this is that they share two congruent angles. Let's go ahead and take a look at our third and final problem. So for this one, make sure again you have your diagram drawn in. There's a few things, we're going to do this all without numbers. And so we're going to rely on our vocabulary and things we know about parallel lines. So this arrow right here on line TU matches this one on QR. So what that's telling us is that this line segment QR is parallel to the line segment TU. And we're trying to decide, is the triangle STU similar to the triangle QRS? And so we're going to just rely on things we already know, vocabulary that we already know. So the first thing I see is a pair of vertical angles. Do you see a pair of vertical angles? Go ahead and mark them in. So I see a pair right here. Angle S, actually. We have two angles. This is a set of parallel lines cut by two transversals. So we know that these two vertical angles have to be congruent. So angle S is congruent. It's an equal sign with the similar to angle S. And that is because they are vertical angles. They are opposite and they share a vertex. I also know, because these are parallel lines cut by a transversal, that alternate interior angles. So there's a couple pairs, but angle U is on the inside of the parallel lines, as is angle Q, but they're on opposite sides of the transversal. So we also know that angle Q is congruent, because they are alternate interior angles, to angle U. And just by proving this vertical angles are congruent, Q and U are congruent, then that must mean that R and T are as well, which they would be because they are also alternate interior angles, just on a different transversal. And I've gone ahead and written that out for us as well. And wrote our similarity statement. So once we are able to prove that two triangles are similar, we need to write a similarity statement. So notice that we have triangle QRS is similar, triangle UTS. So that is going to conclude our video for today. Please be sure to have all the diagrams filled in.